Good afternoon. Today we want to look at logarithm. We treated indices in our previous class. So let's look at what we have when we have this kind of exponential x. Yes, we discussed that this 2 raised to power x, we should solve it as 2 raised to power x and write this 8 as 2 raised to power 3. Because 2 times 2 times 2, 2 multiplied by itself 3 times give us 8. So I will now say x is 3. So how do we read this? We read it as we are looking for a number that will be the power of 2. We are looking for a number that will be the power of 2 so that we can have a result as 8. That is the meaning of this. We are having a power that will be placed on 2 and we are going to have 8. The power 2 needs to be raised to give 8 as a result. So if you say 2 raised to power 1, we get 2. So x is not 1. If you say 2 raised to power 2, we get 4. X is not 2. If you say 2 raised to power 3, we get 8. X is 8. So if we don't want to write this as an equation, we can write this same statement in a single term, in a single expression, without the need for equals to sign. And that brought us to what we call logarithm. Logarithm and indices, they are saying the same thing, just in different ways. Now, let's look at this. We can write it as log 8 base 2. Log 8 base 2. What does it mean? It means that how many times am I going to multiply 2 to get 8? To get 8, I need to multiply 2 by 2 by 2. That is 3 times. So the answer of this is 3. How many times am I going to multiply 2 to get 8? Please use that ideology. And when you use that ideology, it will make you solve questions easily. So let's go further. We want to look at laws of logarithm. In our previous class, we look at laws of indices. And here we want to look at laws of logarithm. So we are going to look at the addition and subtraction law. What does it mean? If we have a logarithm that is having a base and another logarithm that is having the same base, can you see? They are both to base q. The law says that we should multiply their power. Log PR, P times R is PR. So it's going to be log PR base Q. Log PR to base Q. If we have QR, don't forget, this thing go the two either way. If I have something this way and I want it to use it, I can take it to this way. If I have it this way and I want to split it, I can split it. That's why some people can call this law product law. If they have a product, they can split it into sum. If you have a product, we can split it into sum. If you have a sum, we can combine it as what? Product. Now, if you have subtraction, we have log to a base q to a particular base, another one to base q, log p to base q minus log q, log r to base q. Instead of doing these things separately, the law says that we can just divide p by r, that is p over r. Then we find a logarithm of the result. So instead of having to do this thing one by one, the law has given us a way to do it just once here. So don't forget, this is very, very important. When we are adding, we are multiplying the power. And when we are subtracting, we are dividing the powers. So let's look at this. This is another law. This law says that if you want to find the logarithm of a number, and the number is also equal to its base. Now look at it. How many times am I going to multiply q to get q? It's just once now. How many times am I to? I just write one q there. It's just one. So that's the answer is what? 1. Log q base q is 1. How many times am I going to multiply q by itself to give q? It's just by writing ordinary q. Because if I multiply q by q, I get q squared. And what is at the top is q. So log q base q is what? Is 1. So no matter what it is, if I write log 25 base 25. So far the logarithm I'm looking for is also equals to the base. It is 1. We now have another law, the index number. Now, if we are trying to find the logarithm of an index number, look at it. This is a number in exponent form, something raised to power something. The law says that we can take the back of this place. So we can now have m log p to base q. And also, if we have this here, we can also bring it to the top of whatever we have here. So don't forget, the law is not just one direction. It can go forward direction, it can also go backward direction, depending on how it is useful to us at the moment. So don't forget, this is index number law. When you are finding the logarithm of an index number. Now, logarithm of 1. Logarithm of 1 is logarithm of 1 to any base is 0. You can see this one is very, very easy. If you try to use the law that we just finished, I can write log q. According to law of indices, this one, I can write it as q raised to power 0. And this law that we just finished said the 0 can come to the back. And you know, 0 log q to base q. When you multiply anything by 0, what do you get? 0. So log 1 to any base is 0. So we go to negative log. Instead of finding the negation of a log, instead of finding negative value of a log, we can just find the reciprocal. Look at it. From the law that we just finished, this law can also help us. Now, remember that we did a law that says we can write this as log, this is log q, this is p. The minus that's back here, we can bring it to the top here. P raised to power minus 1. Now, in law of indices, don't forget, log to base q, we can write p raised to power minus 1 as 1 all over p. And that's what we have here. Also, we can also write it, instead of finding the reciprocal of this, of the number that I want to find the logarithm to base q, we can also find the reciprocal of q also. So this one, it can be written this way, and it can also be written this way. So take note of both. Now, this second one, you're going to see why it is true later. I'm going to show you why this is true when you learn a law that you can use to verify it. Okay, let's go. So we now have what we call index number, index base. You can see we have a logarithm. We want to find a logarithm of a number that is in exponent form. Something raised to power something. And also the base is an exponent form. The law says, don't waste your time. Just pick the power of the first one and the power of the second one, then divide them. That will be m over n. Then write the logarithm again without the m and n. That's without the power, pq. You see, I'm going to be using this law very well because this law makes something easier. When I'm working with simplification, when I'm trying to, simplification, I'll be working with this. But when I'm working with equation, I can work with it anytime, but you see the way I'm going to apply it, I'm going to apply it a lot because it will make life easier and make us to be able to solve questions very fast. Now, look at this. Number raised to log. This is another beautiful law. Number raised to log. You can see, instead of log being down, log is being used as a power. You can see log is being used as a power of q. And to our surprise, even the log is also having base q. The law says that if such thing happens, that something is raised, is carrying a power of log, and the log is also having the base, this is going to be cancelled out. So our answer is going to be what? P. Please and please, I'm going to use this law a lot. Let me give you an example of where I will use the law. Now I have log 8 raised to power log 8 base 2, and I have x. Instead of wasting my time, I will just make this one, the whole of this log, as power of 2, so that the log can destroy. Because I'm making it power of 2, I have to make this x also a power of 2. Because I allow 2 to carry this log, and I allow 2 to carry the x here. I did the same thing to both sides. So you can see the logarithm is destroyed. So I'm having 2 raised to power x equals to 8. You can see how it makes life easier, and I can easily solve this. We have not got to where we are going to apply them. These are just explanation for you to understand the law. You need to sit down and go through these laws and make sure you understand them very well. Now, we have a change of base. This is the law. The law says that instead of finding log p to base q, it's just as if p is a boy who wants to go and fight q in its own compound. P is a boy who wants to go and fight q in its own compound. So we can decide, no, we don't want p to go and fight q in its own compound. Let's create a neutral compound. Then it means that p will go to a neutral compound, log p to base x, which is a neutral number there. Then log q. Can see q is no longer base here. Log q to base x. Let me write the x is the same to base x. Can you see? I have created a new base. So this is very, very important. The other time that I showed you, okay, let me quickly use that opportunity to expatiate on that. Now, to expatiate on that, I have log, that place I told you log q, and I told you that log this is the same thing. When we are doing that negative law, I said there's a law that will let you know that these are the same thing. That said, when you remove a negative number, you can either make the number the reciprocal or make the base the reciprocal. Now let's look at this law. Let's use this law for it. If you use this law for it, this is going to be log 1 all over p. 1 over p is p raised to the power minus 1 over log q. And you know that we say this 1 can go to the other side there, the power. That's going to be minus log p over log q. Can you get minus log p over log q? So let's try and do the other side. Let's try and do the other side. If you try the other side, if I try this part now, I'm going to get log p over log q. 1 over q is q raised to the power minus 1. So log p over minus 1 can come to the back, minus log q. You can see that we've got the same thing that we got earlier. So this and this are the same. And according to the law that we studied earlier, they are both equals to a negative what? Log. Negative log, yeah. They are both equals to log minus log p base q. So let's go. Now we have log p base q. So the law that we just used, what if we decide to change the base to one of these? Okay, let's say we want to change the base to p. This is going to be log p base p. I'm changing the base to p. Log p base p. And this one is going to be log q base p. You can see log p base p, when the logarithm of the number I want to find is equal to the base, that's 1 over log q base p. So this thing shows that this one and this one they are inverse, they are reciprocal. So it shows that this one and this one, they are reciprocal. So it means that if I can decide to change a base to the number, I can swap their position. What I just need to do when I swap their position, I just need to put 1 all over 1 over something. You can say log p base q equals to 1 all over log q base p. So this is very, very important. So please go through the laws and ask questions, because in our next class we are going to apply these laws to solve problems, and you're going to get good understanding of it by the time we start that. So thank you very much for your attention.